On today's episode, in continuation of the little series I'm making on sort of beginner projects, the next is this soldering iron kit. Now this is a Hakko kit, and it's supplied with a box, nice box there, and it's a temperature controlled iron, so we have a module here to be able to set the temperature, and holder for the tips and all the other bits and pieces that we will assemble. Now it comes with one soldering iron tip, which is a sort of a knife blade edge. That's useful for drag soldering and things, but it wouldn't be my tip of choice for the beginner. So on the site there is also available a selection of different profile bits which we'll be looking at, and one of the advantages of this particular system is that each element is included with the tip. The tip has the temperature control, the component for measuring the temperature, and the heater all in one, so it's a very reliable system. So we'll be looking at how to put this together. Now the kit does not include a power supply, and there's in the instructions it gives you a selection of different voltages and the equivalent soldering iron watts that will produce. Now this is an old laptop supply which is 19 volts and capable of about 3.5 amps, and with that type of supply the power is equivalent to about 40 watts, which is the same as my regular soldering iron, which is the venerable old Weller. So it will be interesting to compare its performance against that. Just before we start the build, just show the web page for the unit, and looks like there's a discount coupon available at the moment. And as we scroll on down, it does warn you that you need to have some skill or knowledge to put this together, so that's why I'm making the video. And also on this link here there is the user manual and another guide in a zip folder. Now if you open that zip folder, you can see that there's a document and the manual. Now the document is in Microsoft Office docx format, so not everybody may be able to open that, and most bizarrely of all, the English manual is an Excel file of all things. So it's pretty much the only time I've ever seen descriptions, photos pasted into an Excel spreadsheet. It's quite bizarre. So to help folks out, I've converted both of those files into a more acceptable .pdf, and there'll be a link down in the description to those files. So the first thing we have to do is to assemble the temperature controller onto the front panel, and to install the LED for the temperature. Now on here there is a little piece of tape just to protect the unit. We don't need that, so we can remove it. And on the LED, the longest leg is the positive, so we put that in, but we don't know exactly how far for it to get to the front panel. So if we simply pre-assemble that, then we can push the LED through, and then we shall know where to solder it. And you need, it's a bit of a catch-22, but you do actually need a soldering iron to make the soldering iron. So hopefully you'll be able to borrow one, or you have one already that's suitable. So I stress again, this has got to be quite a fine tip, because you don't want to be bridging any of the adjacent components here. So that's that. The other thing that we need to do is to put what they call the aviation plug and socket, this that connects the iron to the controller. So this goes onto the front panel, and there is an indentation at the top there, which they recommend to go upwards. So this is going to sit like this. So what I've done with the socket correctly orientated, put the nut on the back there, just a pair of pliers. So just before we do the assembly, there's a little screen that just sits in there, and you don't need to glue that at all because it's going to be held in against the front there. So now if we offer that up, just before we solder, we'll put the nut on the front for the temperature control. Don't need to over tighten that, just to sort of nip it up. So that's ready to be soldered now. Good. So now we can get on to the next stage. Now for this next part of the build, I'm going to be diverting a little from the instructions due to the power supply that I have. Now I cannot put the mains socket in here because the mains socket is built in. So all I'm going to do is to stick this with this double-sided sticky tape. I've cut off the little supports inside there so it will sit on the base, and I've also had to remove the grommet that was at this end because it was interfering with the circuit board. So the idea is I place this, press it down on that double-sided tape. Now there's my mains input there, and I'll get the wiring done. Now I cannot switch the mains side of this, so what I'm going to do is with the switch, I'm just going to switch the positive from the power supply. So in my case I need to remember to actually unplug it from the mains when I've finished. So here I've wired up the power supply, and as I said, I've done things slightly differently because I'm not able to switch the mains side of this. So the positive to the unit goes to one side of the switch, and the positive from the power supply goes to the other. On this particular power supply, the earth and the minus are joined together. So I've joined those together there, and just put a bit of sleeving over that. And for anybody just starting out in soldering, you can see how sort of shiny these joints are. Shiny is good. If you see anything dull or anything that looks like it's got a big blob on it, then that's generally bad. So all your joints should be shiny like this. So next we've got to make up the lead to connect the unit to the soldering iron itself, and I've just cut back a bit of the outer sheathing here. So to put this socket on, first I've had to unscrew the cable clamp so we can get the cable in. And when we disassemble it, there's a little sleeve that goes inside, and the socket itself. Now the socket is numbered. I'm not sure if we can focus in on that. You can just see the numbers on there. It runs round from number 1, 2, 3, 4 to 5. So we can work out which pins are which. There's a good diagram in the description. So to work out the length of the cables, if we pass the cable through to here, now we can see that actually it's best to do it outside. This is going to screw in as far as that, so we know where that's going to sit, and this needs to clamp onto the cables. So if we cut these cables to about this length, then all should be good. So we'll put that inside, then the cable clamp will go onto that, and there's our connections there. So let's get that those stripped back and tinned and put that connector on. So here's a sequence of stills I took whilst I was assembling the socket. Found it easier to use a clamp to hold the socket just whilst I tinned each of the connectors, which you can see there. And secondly, I stripped the ends of the wires obviously and tinned those also. It's a good idea to have both surfaces tinned before you try and do the final assembly. In the final assembly, just tap down each of the connectors in sequence, and that makes a nice neat job. So here we can see the completed soldering for the socket, and all that remains to do is find out where the little sleeve's gone. Oh, there it is. Slide the sleeve forward, then gently push that inside, and keeping the cable still, just screw up the outside of the barrel there until that's tight. Doesn't need to be overly tight. And then finally just snug that up to hold the cable in place. You don't want that twisting around. Again, there's no need to over torque these things, just so that it grips that cable. Good job. On to the next task. So one important point that's pretty much overlooked in the instructions is, before we get carried away and solder the cable onto the holder for the tips and the elements, we need to pass it through the holder itself. Don't forget to do that, because if you forget, then it's not going to be possible to do it afterwards. Don't ask me how I know that. So the next task is to assemble the holder for the tip, and this comes with a little vibration sensing switch, so that turns the iron on when you pick it up, and it has a gold coloured side and a silver coloured side. So if we can focus on that, you can see that. Now the gold coloured side goes sort of uppermost, if you will, so that needs to go in there. And also I've prepared similarly as before, just sort of offer it up and do a measurement, and pre-tinned those. So let's get those components soldered in place. It's always tempting when cutting these wires off to just let them ping around, but that's not a very good idea, because eventually they will find themselves somewhere where they're not wanted, and an expensive piece of equipment could get blown up. So don't let those pieces that you cut off just fly around, because it will cause you problems one day. So there we are, and the final job here is to use this tie wrap that they provide to just fix that onto the circuit board. So that's that step complete. So now we're in position to assemble the handle completely. So this part will pass through here, and there are a couple of locating slots. You can see those. Yes. So that will just gently push down in there. So with that located in place, the element tip assembly, this ferrule goes on there, and that's held in place with this little locking ring. And this part obviously screws on here first. Okay, and this has got to pass through. Just make sure it goes right until this part here is just touching the top there. So then it will make contact with the little springs inside, and we can finally do that thread up there. So the first part of the test now is obviously just to switch it on, and it says in the instructions the Nixie tubes should display 500. Well, I haven't seen Nixie tubes in many a year, and this is an LED display, but indeed it does show 500. Now if you twiddle the knob here, you can obviously adjust the temperature, but as there's nothing attached, it'll just flip back to 500, and there's no LED here. So clearly what we have to do next is to connect the iron itself. Now, I don't have a holder for this right now, but let's improvise. So we switch on again now with the iron. We're going to set the temperature to about 300, I think. So it's now stabilized at 300. So if we get some solder, we can see that it's working fine. So I've made myself a little stand and put a wire thing in here to clean. Now there's lots of debate about how to clean best. I was using a damp sponge for decades, and but the latest thing seems to be these wire brushes, if you will. This is just simply one that you would use for washing up. Works as well as any others. I've seen them allegedly gold and brass and all sorts of nonsense, but this works for me. I think the major difference, as far as I'm concerned, is that if you want to remove oxidization and actually remove the solder from the tip, then you go with the damp sponge. But sort of between soldering operations, just a quick poke in there does the job. Now, as I said in the beginning, this sort of knife edge type tip is not really what I would normally use. From my Weller iron, this is the type of bit that I'm using, and you can perhaps just make out that it has a little flat edge on it. And in the case of the Weller irons, the temperature is set by this magnet at the back, which has a number on it which sets the temperature. Now I'm not going to get into Curie and the magnetic effects caused by temperature change, but suffice it to say that's the type of bit that I've been using for many years. Now, in the Hakko selection, I bought these 4 as a set. There is a very similar looking point there, tip. So I'm going to be changing that out for this one. Also in the set, there are a couple of just sort of normal rounded end ones, different thicknesses for different jobs. And last but not least, I have another, at least another one. Here's another Weller iron, which has got my finest tip on it, used for surface mount and that sort of micro controller type work. And also in the kit here, there is an extremely fine tip as well. So with these, I think you'll be well covered for pretty much any situation. So I'm just going to swap that tip over. So again, that's the ferrule, which needs to go onto the new tip. Make sure that that is well seated in there, and just for comfort I'll turn the point around like that, snug that up, and we're ready to go. So if we just test it out, so we can see it beginning to smoke there. These come pre-tinned, and we're now up to the required temperature. So just to test that, yep, that's working a treat. Now I'm using leaded solder as well. I'm not a fan of unleaded solder. Just produces brittle joints in my opinion, and I've repaired enough stuff to dislike it. So as a final thing, I'm just going to do some practice soldering and see how that goes. So I'm quite impressed with the speed at which it heats up. Let's see. I think I make that around 10 seconds, maybe 12. So that's quite respectable, and certainly faster than my Weller. So let's just tin the iron there. And even that joint there where the crottle clip is holding, made a good joint. So yes, I'm very impressed with this guy. Whether it's going to replace my Weller, only time will tell. You'll have to keep watching the videos.